Welcome to this brief presentation on how to support your elementary age child with math, whether it be the pandemic or not. I'm Barbara Rappaport, and I'm a math specialist, having worked in math education for 31 years, grades K through 8. In addition to being a classroom teacher, I have been a department chair and math coach, deepening the math knowledge of teachers, along with providing effective strategies to be used in the classroom. Throughout my 31 years in math education, the question I was asked most often from parents is, how can I help my child with math at home? And this question has only increased in frequency and changed a bit in later years since the Common Core to, how can I help my child with this new math at home? And now that many children are learning remotely, either full-time or part-time, parents are in need of even greater support. In response to these questions, I have decided to put together this video. This is what you can expect. I'll be talking to you today about why and how math looks different today. I'm going to explain the underlying strategies and philosophies that are used to teach concepts in math. We'll take a shallow dive into what number sense is and why it is so important. And finally, I'll be providing some simple math activities that you can do at home to help your child build number sense and become a more flexible math thinker. So let's get started. Many parents express how hard it was to help their child with math at home, as the problems seemed to be harder, with longer, more complicated steps, in place of the arithmetic that we're familiar with, where providing an answer was good enough. So, is there really new math? I don't believe so. Has the way we teach math changed? Certainly. With the inception of the Common Core across the nation in 2010, the expectations for learning outcomes in math have changed. Simple calculation is no longer the main goal. In today's math, students are being taught to understand how and why mathematical operations work, so that they are prepared to apply this knowledge to new situations, both in and out of the classroom. They are taught to be critical thinkers. In my experience working with teachers and children, I have found that because of these new expectations and standards, students and teachers have a greater understanding of how math works and are actually feeling more confident in math. Take a look at this video.
So math in some ways is like baking, and math used to be taught as a recipe, as a series of steps you do, and then you get a result. And what you understand if you're a cook or a baker is that you add things in certain proportions for a reason. And that, your cake has to have this percentage of fats to this percentage of flour in order to work. And what Common Core tries to do is to do the same thing with math, sort of developing what they call number sense. And number sense is understanding more or less why we do the things we do.
So, math is no longer just a recipe where one just follows the steps or procedures. Now students are taught the why behind these steps. Children are expected to understand what they're doing, so they're able to apply this mathematics in new situations or when in the classroom. Tips and tricks, they're nice and they're convenient, but they're not very helpful when children eventually face more advanced math. Now I'm going to share another little video with you that will show you that you are not alone in what might be doubts or frustrations with the way your child is learning math.
Core is taught in a way that most people over 20 don't recognize.
We find ourselves tearing out our hair at the new math.
It's the same thing I do when I get a check at a restaurant, draw a bunch of shapes and tell the waitress to find my error.
Parents taking to Twitter, posting unbelievably complicated homework assignments.
These math problems circulate that just seem really nonsensical, which is really frustrating. If you have a kid who has this simple problem that looks like it's being made way too complex for no reason, it's totally understandable why people would say,
"Oh, no,
this recipe that I learned is the quick and easy way to do it. Why aren't they just teaching kids to do that? So for example, we all learned to borrow when we subtracted, but this doesn't really show you what you're doing. It doesn't really show you what borrowing is. And so
I'm sure many of you can relate to the feelings represented in that video. So how do we help students achieve this goal of understanding the math? We use the instructional approach called CRA, Concrete, Representational, Abstract, when teaching concepts in math. The next few slides will go into further depth as to what this means. To start, students learn mathematical concepts using actual objects or situations. All children must start at this stage. They can use chips, blocks, cubes, beans, paper clips. Any household item will do. Concrete models tie mathematics to the real world and include anything that the child can use physically to represent a problem. For example, to model 35 plus 42, students might use base 10 blocks, where the rods represent tens and the cubes represent ones. As you can see here, we have the blue representing 35, 3 tens and 5 ones, and the red representing 42, 4 tens and 2 ones. And when the child moves these around and puts them together, they can see that they now have 7 tens and 7 ones, yielding 77. By combining these numbers, by breaking them apart by place value, tens and ones, students are able to see how and why this statement is true, just by using concrete materials. Or, to model the multiplication fact of 3 times 4 equals 12, students can use objects such as paper plates and cubes to concretely model this and see why and how this works. So they now see that they have 3 groups, 3 paper plates with 4 cubes on each. By now they know how to skip count, 4, 8, 12, and they can concretely see that yes, 3 times 4 does equal 12. The next phase is the representational phase. A strong connection must be made between the concrete and the picture and/or representation. In this stage, children are able to use visual or pictorial representations to represent the concrete examples. Moving to the representational stage, the student may then draw a similar image to the concrete model they created. As you can see here, the student has drawn 3 circles with 4 happy faces, just like what they built with the 3 paper plates and 4 cubes. This representational stage provides the mental scaffolding for children to move their mathematical understanding from the concrete to the final stage, which will be the abstract. The goal is for the children to see how pictorial representations tie to the concrete examples. And finally, the abstract phase. This is where we use numbers, letters, and other symbols to provide a short, more efficient way to represent the math ideas. This is what we're all familiar with. Once the child sees what's happening, they use symbols and standard algorithms because now they understand what makes those processes work. A strong connection must be made between the concrete, the picture, and the symbols, or the abstract. The abstract level of thinking represents mathematical thinking symbolically. It is important to realize that this is the final level of understanding for children, and that we must help each child through the first 2 stages before they will be able to grapple with the abstract. Now you can see the progression of this 3 times 4 equals 12, from the concrete paper plates and cubes to the pictorial happy faces inside circles, and now these abstract things called numerals. 3 times 4 equals 12. Flexibility is a key focus of today's mathematics. Back when we were learning math, it was all about speed and accuracy. The goal in math today is fluency. Now, fluency does not necessarily mean speed. Fluency today is defined as accuracy, efficiency, and flexibility. Our children should be able to work flexibly with the numbers and computational methods they choose. They should be able to understand and explain these methods and produce answers accurately and efficiently. Speed is really no longer a factor. Children need to be able to work flexibly when dealing with basic facts and extending their knowledge to a new task. By seeing the relationships between numbers, we build a child's number sense, which promotes thinking instead of just computing. So exactly what do we mean by number sense? At early stages, ages 3 to 5, children can answer questions such as, how many spoons do you see? Which is more? How do you know? What's one more? In elementary grades, they experience working with place value, ones, tens, hundreds, composing and decomposing numbers. That means putting them together, breaking them apart. Understanding how the basic operations of addition, subtraction, multiplication, and division work, etc. Children with good number sense can estimate, talk about numbers, compute, perform mental math, and judge the reasonableness of their answers, which we all know is so important. So why is number sense so important? Number sense is the strongest predictor of success in higher level mathematics. It is the precursor to fluency, being accurate, efficient, and flexible. And we do know that rote memorization, when emphasized over sense making, inhibits the development of number sense. So how can you help your child? I believe that fostering a growth mindset is the first and probably the most important step. Let me share this quote from Joe Bowler, a professor from Stanford University who has done years of research and is the leading voice regarding this matter. The parents' math knowledge did not turn out to have any impact, only their level of math anxiety. We do not know what parents with math anxiety say to their children, but it is likely they communicate the negative messages we know to be harmful, such as, math is hard, or I was never good at math in school. It is critical that when parents interact with children about math, they communicate positive messages, saying that math is exciting and it is an open subject that anyone can learn with hard work. It is not about being smart or not, and that math is all around us in the world. And I can't emphasize how important this is. This growth mindset, as opposed to what we call a fixed mindset, which is I can't do this, I'm not good at this, really makes a difference in how a child succeeds in math. So some do's and don'ts. Encourage your child to play math games and puzzles. Always be encouraging. Be a cheerleader. I know you can do it. Encourage number sense. What do I mean by that? Here's an example. I see 6 blueberries on your plate. How many more would you need to make 10? That's a simple example of building number sense. And of course, encourage a growth mindset. Things to avoid. Don't tell your child they're wrong when working on a math problem. Try to find the logic in their thinking. Don't associate math with speed. Do not share the idea that you are not good at math, that you don't like it. Most parents don't tell their children that they were not good at reading. They want to encourage them to read. We need to do the same with math. And do not encourage a fixed mindset. How can you support your child at home? with homework, by staying involved, learn with your child, you'll become more confident of supporting him or her. Use questioning techniques rather than teaching them the way you learn math. How do we know? What do we know? What do we know? What do we need to find out? What do you think you need to do? Can you explain it to me? If a child can explain to you how to work through a problem, that will solidify their learning. If they're explaining it to you and they're having some confusion, it will give you insight as to where that confusion is. Some other things you can do with your child. Play math games and puzzles. Greg Tang Math is one of my very, very favorite websites. And I will warn you that you might get lost in that website too. The games and puzzles are very intriguing. Any opportunities with dice will help children enjoy math and develop number sense. If you roll one die with a preschool child, kindergarten, and a 3 comes up, how many more? First, can they identify that it's 3 without counting? Can they just see that it's 3? And then how many more do you need to make 5? If you roll 2 dice and 7 comes up, how many more to make 10? Or which one is bigger? How much bigger? Encourage them to try mental math. Make math a part of everyday life. Cooking, grocery shopping, looking for math in their world. Encourage number sense. For example, solving 29 plus 56. If I take 1 from the 56 and move it over to the 29, I now have 30 plus 55. All of a sudden, that's a much easier problem to solve. But most important, encourage a growth mindset. Thank you for joining me. I hope you found this informative. I'd love to hear from you. If you have questions about this presentation, would like a deeper dive into any of the things I discussed in this presentation, or something else related to supporting your child with math. I'm also available to work one-on-one with parents and children. Thank you for taking the time to empower yourself so that you can be a greater support for your child. You can reach me at barbara@satelliteprep.com. Again, thank you.